You have a register
Hello. So was your recording helpful?
Yeah, but the random program, it didn't work. When we want to compare the results of multiplication with a large number. If it is less than that number, we want to jump to that one. So but it didn't jump. We exactly did that one. With subtraction, it didn't work. We did it like several times.
Okay.
Can we do one example?
Yeah, we can do an example.
Yeah, just like X.
Well, but you want me to talk about the solution of Read 16, the Base 16 program first, right? So we can do that, which is a good reminder of stuff.
Exam too early.
Exam 2 early is for my Friday class. Yeah, one person is trying to take it early today, so that's why it's, quote unquote early. Okay, so this is our exam 2. This is for our class, cisp310, and this is the first time we take it, in the lab. So I just want to kind of go over the rules and whatnot. So basically, you can use your virtual machine. I think most people would be using a virtual machine for this test. Is anyone not going to use a virtual machine like they have a native installation of Linux? Okay. And the network connection has been reliable in the lab, the Wi-Fi? Yeah? That's a better idea, have a fallback plan. Okay. So personal laptop computers are allowed. Okay, so if you have your laptop computer that is ready to go, you can use it for your test. You can use Google. You can use any type of search engine. The only thing you cannot do during the test is live communication. During the test regarding the material for the test. Okay, so that's the only thing that you cannot do. So I would have people to put their cell phones away. If you need a calculator, you can use the calculator in Windows or in Linux. I mean, I'm pretty sure you can find a variety of calculators for either platform. If you use the USB on the drive or virtual machine on the drive approach, make sure that you have a backup just in case the drive goes bad on you during the test. It has happened in the past. And there are some constraints here. You can use any resource as long as it does not involve communicating with somebody else during the test. You can look up, you can review the notes, you can use Moodle, you can use Wikipedia, you can use Google, you can use just about anything, really. The only thing you cannot do is email, instant messaging, SMS, use your phone, ICQ, and so on and so forth. So those are the only resources you cannot use during the test.
What about IRC?
IRC? Any live communication. If someone has posted questions in the past and you're looking at a log of that, and if I can see that, that's probably okay. Yep.
Can we have playing quietly on our earphones music so long as the device that's playing them is out of reach, such that we couldn't possibly be changing the tracks to have the answers to the questions that we want on them playing at any given time?
I would rather not.
Sure.
That's why I recommended the Harbor Freight muffler. I mean, not muffler, earmuffs. Yep.
Would you be willing to stand at one end of the lab and lecture all throughout?
What?
Having something soothing in the background noise is very helpful.
Soothing background noise. Thank you. That's a very good description of my lecture. Yes.
Are you going to give us like the sample test, the test cases that
The test cases for the sample test?
Yeah, you gave us so we could test our code, the numbers that you gave us for LCM.
Oh, the LCM and GCF?
Yeah. So are you going to give us in the exam too?
Yes, the bottom of the question actually has a few test cases.
Okay.
So, it is not exhaustive, but it does give you a few of the more common test cases. most likely than not, if it works for those test cases, it should be okay. Because I think I thought of most of the kind of boundary test cases in this case. All right. Well, so the first thing we want to do is something that I did not do or I forgot to do, which is the solution of the previous homework assignment. I have not talked about that yet.
Have you posted
Read
it?
base 16. What?
Have you posted it at least?
I don't think so.
No, the second one.
The second one?
Yeah, you posted the spaces and the subroutine.
Yeah, so read base 16 is the one that I have not posted. Okay, well, let's go ahead and do this one. It's a good reminder because, some of these concepts will still be in the test today. So this is a good reminder. It's a good primer to prime your brains, just to get ready for tonight's test. All right. And I have tonight's folder already done. I can probably upload the zip file early, fast enough, for tonight's exam, but the video may not be available, because that takes a little bit of time to upload it. So you may not be able to watch the video that is being recorded right now during the exam, later on tonight.
So that's why
Yep.
we go over all the
If we want it,
right
can
now.
we get it?
Hmm?
If we want it, could we have you copy it to a flash drive beforehand?
I will see if I can push it online, but if I cannot, I cannot. I cannot just make it available to you or a few other people with a flash drive right now.
I'd be willing to pass my drive around for anyone who needs it.
Okay. All right, let's do the homework. Okay, so for this homework, we want a folder called Base 16. So we'll go ahead and create a folder called Base 16. For the exam, I will give you a file so you can just basically untar that file. It will create a folder with a few files inside, including a make file. So you won't need to make your own make file, to get the convenience of using make. All right. All right. So this is the question. The question is, we want to name the program base16.s. So we'll go ahead and copy and paste the source code. Now this is the other thing. In the question tonight, I have the pseudocode along with the code, the assembly, the code that is wrong. So the first thing you want to do is to find out how the high-level code correspond to the low-level code. So try to make the mapping as much as you can so that you can identify which part of the program is trying to do what. Okay, it is very similar to the practice test that you went through last week. So it's going to be very similar to that. Base16.s. So basically, as I go through this, I will try to identify places where it's just important to know, not particularly related to the test. Base16.s. Okay, so here we want to go from line 4 to line 15. Okay, do you guys have a question? No? Okay. How about you?
What did you just do?
I just shifted a bunch of lines. Okay. So from line 6 to line 14, 6 to line 16, shift. Oh, too much. Line 6 to where? Line 14, shift. And then here we have just one line. Uh-oh. This else corresponds to...
You just need to indent the line below else.
No, it doesn't... Oh, okay, this... I see. Unindent.
Yeah.
Okay, there we go. All right. Okay, so now that we have the source code, already written, there is one question. Okay, there is one subroutine that you have to write from scratch. So keep that in mind. Just like in the practice test, you have two subroutines that you have to debug and one that you have to write from scratch. The ones that you have to debug has about the same complexity as the one that you encountered in the practice test. So they would have loops, conditional statements, and the same sort of stuff may be missing or wrong. So you just have to spot all those things. The The one that you have to write, I recommend that you do it, kind of the same way that I do. Start with the pseudocode and then interleave your assembly code throughout the high-level code. So that would be, I think that's the best way to do it. At least for me, that's the best way to do it. Yep, question? Nope. Okay, I thought I saw a hand. So now I just insert, comments in front of all the lines here. Okay, one thing is, in the data section, in the test, you cannot change the .data section. So do not make any changes to it, do not add to it, do not remove anything from it, just don't touch it. Okay? And that's, and I wrote down too, if anyone touches that, I won't grade it. All right. So now we have an unsigned integer, which is 0. We also want to have a Boolean. Now, there we go. So now we can go into the subroutine. Go into the actual code .text. Now, whenever you have a loop, you have to you have to create a label for the beginning part of the loop. That does not depend. That has to happen regardless of whether it's a pre-checking loop or a post-checking loop, because you have to go back to an earlier point. So if you're dealing with a loop, you might as well just define a begin label for the beginning of the loop. You can call begin do, begin loop, begin while. Take your pick. But you do have to make sure that you have a begin label for the entire loop. To try to read a single character from CH into CH from standard in, that's just reading from standard in, which is file handle 0. So we'll go ahead and set up the system call here. Move a 3 into EAX. Move a 0 into EBX because that's standard in. I found that if you move a 1 into EBX, it works too. I did it by mistake, and the program just it still worked the same way, which is kind of strange. Okay.
Don't have a character to read.
Yep. So we'll allocate that here. CH is .byte. So. And now we have to move the address of the buffer into ECX. And last, we have to specify how many characters to read. That's in EDX. And then we need to ask the operating system to go ahead and do it. All right. So this statement here, if a character was read into CH, that basically is asking, did we read anything? Okay, that's what it's asking. Did we read anything? I forgot one other thing too, because here I want to initialize end of input to be false. This is okay, because end of input is initialized to 0, which means false. But if I want to be double check, and make sure that I have it 0 before the loop, I really should do it. I really should do the initialization here. Use a move byte $0 into end of input. Yep.
While you're there, you might consider putting your global start.
Yeah. Details. Okay, so how do we check whether a character was actually read in CH?
See if EAX is greater than 0.
Check EAX, exactly. So we want to do a compare long, compare 0 to EAX. And what do I want to do? Because I want to continue into the conditional statement only if I read something. If I did not read something, where do I go?
Else with JZ.
We want to go to here, and we want to use JZ. Very good. So we want to do a JZ to alter if or alter else. Okay, if you want to just simplify the whole thing. So we have alter else here. Now, if we know that there's an else here, that also means that by the time we get to here, we should jump around the entire outer conditional statement to jump to the end of the outer conditional statement. So that means, at this point here, you might want to just, say, jump to outer if end and locate the end of the outer if, which is right here. Okay? Now, if you decide not to use that label later because you want to shortcut it and you implement something that is equivalent to break in C or C++, that's fine. But I would much rather to have something that is redundant, that is not wrong, to make sure that my program would not would not be incorrect later on. All right. So if we continue on, after the JZ, that means I did read something because EAX is non-zero. So that means I have to do the comparison. Okay, first I have to compare and see if it is between 0 and 9. That would be pretty easy because I can compare byte. In this case, it is the ASCII code of 0 versus CH. Because I can use up to one memory operand, so this works just fine. I don't have to move CH into a byte-wide register first because I can use up to one memory operand. Okay, and here we can say J, if CH is below the ASCII code of 0, then we want to branch to the else inside the inner. Okay, so we want to go to the inner else if. And the inner else if is right here. So I would define the label like right away, inner else if. It's right here. If I continue, that means CH is not below the ASCII code of 0. So that means I have to check the second condition because I need both conditions to be true for the entire thing to be true. So in other words, I'm looking for another reason to skip around. So this time I have to compare byte, the ASCII code of 9 to CH. And I want to say if the ASCII code, if CH has a code that is greater than or above the ASCII code of 9, then I will branch around also to inner else if. Now, if you know the odd ordering, of 0 to 9 and then A to F, one of these is redundant. I think A 0 to 9 is below A to F, so anything that is below 0 is automatically below lowercase a. But since but we don't need to rely on that fact, okay? Because this is not incorrect. It is just that during runtime, it will just waste some extra cycle for the second comparison. So it is still correct to do it this way. It's just a little bit more redundant. You have a question? Sure. But if I cannot keep track of my own program, I'll blame it on people because the font is too big.
Font is always too big.
Because now I have to stand back. Well, I guess I can push the monitor all the way to the front, and yeah, it will still work. When the font is too big, I cannot see enough lines in my program to program effectively. So it still works. It's just not as effectively as I would like. Okay, and then the other thing here is at the end of this this branch, I also want to make sure that at the end of this I do an unconditional branch to the end of the inner if. So I would just branch all the way to inner if end. And I'll locate the inner if end, which is right here. So I'll define the label, inner if end, and just define it here. So you can see that when I write this program, I did not write it sequentially from top to bottom. Whenever I define a label or whenever I define a jump, I define the label and vice versa. All right. If we get to this part here, that means I did read a character that is in ASCII code between 0 and 9. And now I need to do the calculations. The calculation is I have to multiply n by 16 first, and then we add the ch and then minus 0 from that. Subtract the ASCII code of 0 from that. There are several ways to do this. N, if I remember correctly, is a 32-bit number. Is that right? Mm-hmm. Let me check. N is 32-bit. Okay, very good. This is another cool feature of VI. You can define bookmarks. It can define I think all the lowercase characters can be used as bookmarks. So you have 26 right there. But I think that's not the limitation. You can actually have more bookmarks than 26. I find it to be really useful because I can now define bookmarks and jump to different places and be able to return to other places really quickly. Okay. So since n is a 32-bit number, and did I assume that you guys know how to use the mode instruction in this assignment? No? Okay, then we won't use it. Then we won't use it. Well, because we don't really need it. That is the same as multiply by 16. Because 2 to the power of 4 is 16. If I double EAX 4 times, it is the same thing as multiplying it by 16. Okay. Then I have to add the ASCII code of CH and then subtract I have to add the value of CH and then subtract the ASCII code of 0 from it. The order does not really matter, okay? So I can actually do a subtraction of the ASCII code of 0 from EAX first. That's perfectly fine. Then what I need to do is to move CH into another register. There are several ways to do it. This is only one way to do it. I'm going to initialize EVX to 0 first, and then I move CH into BL. Do you know what I'm doing? I'm casting a 8-bit thing into a 32-bit thing. Well, that's one way to do it. There are several ways to do this. Yep.
8-bit unsigned thing.
8-bit unsigned thing and turn it into and cast it to a 32-bit unsigned integer. Integer, not thing. Integer. Okay. And then now I'm ready. So I'm just going to add EBX to EAX. So now EAX has the entire result. I can just move it back into my variable n. So I'm done with this part. Okay, now we are doing this part here, which is really about the same kind of logic. It's just slightly different. I could copy and paste because the structure of the code is very similar to the one before, but I have to be careful when I copy and paste because the jump labels are different. So let me just illustrate what I mean by that. Okay, there are these 4 instructions that I can copy and paste here. Okay, I don't want to jump to inner else if, because if I did jump to inner else if, it becomes an infinite loop. And what I'm comparing to also needs to be changed because I'm not comparing to 0 to 9 anymore. I'm comparing A to F. What I do want to jump to is just inner else and not inner else if, and here is where I should define inner else. It is the else of the inner conditional statement. Is that okay so far? Okay, the other thing is, after this, I also have to do an unconditional branch to inner end if, which is the end of the conditional statement. And now we are ready to do everything that I need to do in here. All right, so let's go ahead and do that. I can copy and paste pretty much the whole thing, except for the constant that I'm subtracting. So we are copying from line 28 to line 37. 28 to 37, copy to here. There we go. So we have the multiply by 16 implemented by line 47 to line 50. We have the subtraction. Now this is the only part that I have to change because the subtraction is not just it's not subtracting just the ASCII code of A because we have we have to add 10 to it. So you can just change your subtraction and take care of that. Is that right?
8 plus 10.
No, it is right. Algebra. Is that right?
So it won't take the expression as it is? Oh wait, no, I get that.
Yeah, it will work correctly because the the dollar symbol is simply telling the assembler, take the following expression and whatever the value of the expression is becomes the source operand. And that expression can be simple, can be just a label, can be a 0, can be an expression. In this case, it is just a general expression, which is the ASCII code of lowercase a minus 10, which is just a regular integer. Is that okay? Okay, so now that we have this taken care of, the rest should work exactly the same way because I'm just changing the constant that I'm subtracting to something else.
You got the 0 and then move long.
The move long 0, that is still needed because it's a typecast. Yep.
We have repetition of code. We should move it out into a module.
Or a subroutine, but this is before we talked about subroutine, so we cannot move it out yet.
We know jump.
We
know jump.
All right. So we only have one more thing to take care of, which is this part here. What do we do in the else branch? The else branch just wants to make end of input true, which is move byte $1 into end of input. That's my Boolean variable. And I have the same thing over here. Okay, so copy, paste. And I should be done with the conditional statements. So now I'm ready to specify whether to get out of the loop or not. And to do this, I just have to do a compare $0 to end of input. And if it is not 0, J and Z, I want to go back. Oh, no, what is it?
No,
JZ.
This one's JZ.
Yeah, JZ to the beginning of the loop. Did I do begin? Yep. And here we define checkpoint. And then we can finish up the program at this point. So move 1 into EAX, 0 into EBX, and ask the system to let us go. Are there any questions, about the process or about, the code that we have written up to this point? You guys can, identify which line and ask me questions about a particular line. No questions? Yep.
You wrote 77 lines of code, didn't check a single part of it yet.
Yeah, bad programmer. Bad programmer. Yeah.
Now /configure make sudo make install. Now /configure make sudo make install. See
Yeah.
if it works.
You
So
just
we'll.
called it base16.s.
Hmm?
You did a -o base.
Oh, this is bad. Because it. Oh, shoot. It will just. Oh,
Undo.
it just did. There's no undo here. Okay, so if you did this during the midterm, what do? You just do it. You just do it again. Yes.
Make file. Can't you just copy all that?
That's exactly.
What?
Can't you copy from the buffer right now using?
There's no buffer because the editor is a full screen editor. It has no buffer. It is not stored in the buffer.
We can copy.
Hmm?
We can copy. In Putty, we can copy.
In Putty, sometimes it depends on which editor you're using. I think in some editors it does not work. It's all right. We'll just do it again.
We've got plenty of time for the test. Why not?
Do you guys want me to do it again, or are you somewhat convinced that the program does what it's supposed to?
I'm convinced that barring syntactical errors, it will do exactly as it's intended.
Okay.
And that while you
All
may
right.
have made a typo or two, nothing critical was wrong.
I don't think anything really critical is wrong. Yep, go ahead.
I was just gonna say that's why you use makefile.
And this is also why I use a screen recorder, because now you guys can just watch the whole thing. Again. Yep.
Coincidentally, that's also why you should have checked it into Git before you tried to make it.
Mm-hmm. Yes.
Still gonna upload?
Hmm?
Are you still gonna upload?
With a 0 byte? Sure, we can do that. Well, in the exam, I do give you a make file, so you don't have to do the assembling and linking yourself. You just type make, and it will automatically, remake all the necessary components. Yep.
I'm gonna check that make file now.
Well, you don't want to trust tech, exactly. So you want to double check that make file. I tried it at home, so it worked okay.
It's not totally wrong.
It's not totally wrong. That is correct. Okay. Any other questions? I mean, unless you guys want me to redo this, all over again. The second time I can do it real fast. Yep.
Could you try to do the line n equals n times 16 plus ch minus 0 using the mole?
Using
M-U-L-M?
using mole?
Yeah.
Oh yeah. Yeah, that's easy. Okay, let's do that. We just want to implement this one single line in using the mode instruction. So let's go ahead and do that. There we go. Okay, so we just want to implement this one single line using the mode instruction. Okay, the mode instruction is set up. Okay, in the test question, I give you like the summary of how to use mole and also how to use diff-l. In other words, the instruction or the specification of those two instructions is actually in the test question itself, just in case someone forgets how to use those two instructions. Yes.
Are we doing 32-bit multiplication or 64? Do we have 64?
We have something that is pseudo 64-bit. How about that?
Oh my god.
Not exactly. It's pseudo 64-bit.
Can you give us an example after?
Comparing the one that.
Well, I mean, mole, M-U-L-L, the second L means long.
Yeah.
but every time you multiply two 32-bit numbers, you get a 64-bit product anyway. So it is a 64-bit product all along.
Yeah, but when I want to compare that number with something is at label X to jump somewhere.
Okay, we can do that. No, let's deal with this one first, okay? Okay. And this is it. This is how we do the multiplication. Okay, you move, one of the numbers to be multiplied has to be in EAX. Okay, so this is an implied operand. You don't specify EAX as a part of the bold instruction. It is implied. The second one, is specified. I do not remember whether it can take a memory operand, so I just move everything into registers because I know for sure it will work in registers. So the bold instruction will multiply these two numbers. One is n, which is now in EAX, and the other one is 16, which I initialize into EBX. So the product is now stored in EDX and EAX. EDX has bit 32 to 63, and EAX has bit 0 to bit 31. Okay, in this case, because n is a 32-bit number, we can only put it back into a 32-bit number. And as a result, we can just do a move. We can finish up the calculations. In other words, we can do the same thing as before, subtract long, the ASCII code of 0 from EAX, and then also do the other one. Well, okay, let me show you another way to do this. Okay, we'll put everything back. We can put the result back into n first, and then finish this up, adding ch to the whole thing. So we can use an add byte ch. Oh, it won't work because ch is a wait. I cannot have two memory operands, so I have to do a move byte ch into, I'll say al first. Then we can say add byte.
No, you can't.
What?
Yes, you already have.
You have to
What?
just move the entire thing back into.
What?
Never mind.
That should work.
No, I have no use of EAX when I use AL. EAX is done. I copy whatever in EAX into N already, so I'm good.
Should we
That should
initialize
work.
EAX?
No,
No, we're
No.
using AL.
we're using add with carry.
Oh, okay.
Yep. Question?
So you move or initialize EX to 0 before.
No. Nope. No. Okay, this will do exactly the same thing. It will do exactly the same thing because I'm breaking up a 32-bit add into 3 instructions. The first one to deal with the least significant byte, the second one to deal with the second least significant byte, and then the third one to deal with the most significant 16 bits. And it works out the same way. Yep.
Okay, first of all, we should be adding a value less than or equal to 16 to the 0 position.
What?
So there should never be a carry. There should never be a carry past that first byte.
How do you know? I mean, what?
We're adding
There's no
we're
guarantee.
adding a value 0 through 16 into a position that should be 0 if we've done our math right.
No.
Okay, if we're right, if we're adding this to a hexadecimal number,
But what? Okay. What are you assuming to be in N to begin with?
it doesn't matter what's in n to begin with. The multiplication will handle shifting everything to the right 4 bits so that the last bit
Yes.
is 4 zeros. We're adding a number that should be less than FFFF. Or,
Oh,
sorry, that
okay,
should be
I
less
see
than
what you
F
mean.
to
I
a
see
number
what
that
you
ends
mean.
in 0.
Yes, I see what you mean.
So we shouldn't have to carry it all ever.
Okay, but that's a special case. That reasoning works only because we are multiplying by 16.
Because we've previously multiplied by 16.
Yes, because what you're saying is, you can change this to the bitwise OR and it will still work. That's basically what you're saying.
Sure.
Because you're shifting 4 zeros into the thing. Yep.
Why haven't we done this using bit shift that way 4 spaces yet?
Because adding EAX to EAX 4 times is the same as shifting by 4 times. Yes?
Can you do that compare one that I asked you?
Do the compare one? Okay, let me ask you whether people have questions about this one. Is everyone convinced that this will implement the same logic even though it looks different? Yep.
Very last line, that add W.
Sorry?
That add W on the very last line.
Yeah, ADCW is add with carry word. ADCW. ADCB, add with carry byte. Okay, so let's try something else. Okay, let's do a 64-bit compare. Okay, and see whether that works or not. Okay.
No,
Yes.
it shouldn't work. You're not on a 64-bit platform.
Well, we want to see how whether we can break it up into multiple parts to make it work. Okay, so we have X, which is a 64-bit number. 64-bit number means it has 8 bytes, and we'll have Y, which is the same way. Okay. It'll fill everything with zeros. Yep. But I just want to allocate 8 bytes for that. Okay. So the question is, how do I compare two 64-bit numbers, but we're only using a 32-bit architecture? That's the question. Okay. And well, what we can do is, even though we don't have compare with borrow, we do have subtract with borrow. So the concept is to use subtract with borrow to implement compare. But we don't want to change the operands. There are several ways to do it. You can basically push everything first and then pop everything back later on, so that the calculation does not actually affect one of these two numbers. So let's go ahead and do this. Okay, let's go ahead and push y, because I'm going to destroy y in the process, or I'll destroy x in the process. So I'll push x and then push lx plus 4, and then immediately I would write the instructions to pop these two things back into memory, so that before I forget about it, I know that I have to do the pop instructions. Are we doing okay so far? These two push instructions, they use a memory operand, which means we go to the location x, we grab 4 bytes from that location, and then we push those 4 bytes on the stack. And then the next one will go for the next 4 locations. When we pop, it is exactly the opposite. We are restoring the content back into x from the stack. Are we doing okay so far? Okay, with the push and the pop? Okay. So now we have to do the comparison, which is basically subtraction. So the first one is just a subtract long instruction, because we have to deal with the least significant portion first, and then we deal with the most significant portion. So the subtract long instruction is effectively trying to do something like this, but I cannot do this because it has 2 memory operands. So the way to fix this is to move one of the operands into a register. So I'll move y into EAX first, and then in the second instruction, I would use EAX instead of y. Are we doing okay so far? So in this process, I will destroy or overwrite the content of x, and that's why I restore that later on. The second instruction is going to do the same thing, except this time I'm dealing with y plus 4, which is the most significant 4 bytes of y. And once again, I put it into EAX, and this time instead of using SUB, I use SBB, which is subtract with borrow long, and we will use EAX and use x plus 4 instead of x, because we are subtracting with the most significant 32 bits of the 64-bit numbers.
So we want to jump. I want to jump if y is greater than x.
You want to jump if
To
y...
L1. Yeah, to the label.
Okay, so you want to jump if x is greater than y?
Y is greater than x.
If y is greater than x, then you want to basically flip the logic and become a JL or JB to a label.
Yeah, label 1.
Well, we don't even need that, because we can just put a label here and then look at the flags and see if the flags are updated correctly.
No, I want to jump because I want to run it and see.
You want to jump?
Yeah.
Okay. What do you want to do? J, B?
Either one. If x is greater than y or y greater than x, either one.
Okay. Use a JB.
Okay.
Okay, JB to L1. And then we put a no op here, and then we put L1 here, another no op here. And then we'll finish up the rest of the program. Okay. And obviously since we're going to run this program now, we have to make sure that we define all the proper things that need to be here. And we can just put the start label here. Yep.
When we have jump below, you just tell us how to translate it. We had two operands, and we used to say jump.
Yeah,
the
it's
first one
it's the
is below
it is the
other
same
one.
way here.
So how do we say?
It's the same way. We jump to L1 if and only if x is below y. Okay, so we want to make x below y for the branch to happen. So that means it is probably a good idea to do some initializations here. So the x and y are not exactly all zeros. How do you want to initialize x and y?
Well, we'll want to make sure it's a 64-bit number.
Yeah, 8F.
8 f's.
Yeah.
So you want to put this into which number?
That's not 64 bits though.
No, but I can only initialize 32-bit at a time. So I'm breaking up the 64-bit initialization into two move instructions. So where do you want to move this? Into x or y?
Either one, it doesn't matter.
Let's make it tricky. Let's put this into x and put this into x plus 4. So x is basically just f, 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 f. And then what we'll do is we'll put a 0 into y and then move a 1 into y plus 4. So y as a 64-bit number is 1 followed by 8 zeros.
So it's 1 greater than x.
It is 1 greater than x. So the branch should still happen because we are saying branch to L1 if and only if x is below y, and x is below y in this case. So the branch should happen. Is that making any sense? Okay. So let's go ahead and see if we can get this to work. And this time I got smarter. Okay, this is something that you might want to consider doing during the test, is to copy the file first before you do anything with it. So I would use the time as a suffix of the file. For those of you who use get or some other revision control program, this would be a good time to check it in before you do something to it. Just in case you do something as stupid as what I just did with mine. And trust me, it's not the first time I did it either. That's why you can see that I was not even surprised. It's like, oh yeah, I just did it again.
Anytime, can you show us how to do the two comparisons in Vim?
Sorry?
The comparing two files in Vim, like you did that one time?
Sure. Yeah, I can do that. Okay, undefined references to n. All right. Line 3. Okay, I think I forgot to define. Oh, okay. It's because of this chunk of code here. We don't need that anymore, do we? Do you want to remove that, or do you just want to? Or we can just define n here. I mean, just make it happy. Then we also need ch. All right. And make sure we copy the file first before we do something to it. And it just use the
we should put an
time.
L1 up near the top.
Does it use L1?
No, I'm saying maybe we should put an L1 up near the top.
No. Okay, so we assemble, we link, and then we GDB. There we go. Oh, by the way, the make file also has a target, a pseudo target called tar. If you say make space tar, it will create the tar file that you need to turn in for your exam question. So this way it is auto magic, somewhat, and semi-auto magic. Yes?
Excuse me, one
Mhm.
question. When
Yep.
you were talking about the solution of LCM in the video,
Mm-hmm.
you told that let's not be worried about 64 bits like multiplication and division. And if in the solution that you posted online in the video, we just we initialize x and y with a very large numbers, that solution doesn't work. Because we didn't take to account the EDX for multiplication there. So what are we supposed to do in the exam? Do we need to be worried about very large number or not?
In the exam, you will not encounter numbers larger than 32-bit,
Okay.
so you'll be fine.
Okay, thanks.
All right. Well, the moment of truth here. So let's go ahead and put a breakpoint on line 27. Okay, run the program, and we are on line 27. Single step, single step, single step, single step. Okay, so what flags should be on at this point? If I look at E flags, which which flag should be on and which flag should be off at this point. Well, okay, which one do we care? Because we only have one conditional branch after this, which is looking at the carry flag. So in theory, the carry flag should be what? Set or cleared?
Yeah.
It should be set. Okay, let's take a look. And the carry flag is set. The carry flag is the borrow flag, so JB would have branched. Okay, we can actually single step through that, and you can see JB actually branched around the no op instruction, so it worked. Okay, any other questions? Sure. Do you guys want to see whether it works for signed numbers, because this is unsigned?
No.
No?
Not at all. We want to start our
We just
test.
changed the below to L.
Sorry?
We just changed the J to J.
Yeah, but do we know whether the correct flags will be set up here?
We can assume that they will be because it worked.
Because it's supposed to work. Yes.
We can assume that if it doesn't work, it's the processor's fault, not ours.
And it has happened before too. Yes. Question? No? Okay. Any other questions about these topics? I just illustrated how to do a 64-bit to 64-bit comparison, just using the subtraction. Because a compare is a subtraction. You just have to make sure that whatever you destroy, either it is tossed away, or either it's tossable, or you have to restore that later. That's the only thing. That's the only catch. Okay. Any other questions? Stack questions? Operand questions? Mole questions? Diff L questions? Nothing.
I'm just trying to remember, it's been a while. JA, JB, and JZ, or JA and JB are for unsigned, and then it's JG and JL.
Unsigned numbers are easy as ABC.
Okay.
Yep.
If you are doing multiplication, your EDX will be wiped out. Right?
No, it is not wiped out. It is overwritten by the most significant 32 bits of the 64-bit product. Okay, that is actually all written up, in the instruction of the exam. If you read the first part of the exam, I think I have like some 50 lines of comments, just reminding people, how to use the mole instruction, how to use the diff L instruction, and stuff like that. So there are, and also certain debugger tools. I think debugger commands. I think I mentioned those two, like B for break, S for single step, R for run, and stuff like that. Stuff that you should know already, like a few months ago. Yep. Any other questions? Yep.
I just want to make sure when we want to run the code, we just first put make and run
Yeah.
it. And then for GDB, we write the name of
You
the
have to
main file.
Sorry?
For GDB, we write GDB and the name of the main file.
Yes.
Okay.
You say make, and then you say GDB, and then the executable, the name of the executable, which is the same name as the source file, but without a .s extension, which is the same way that we have been doing things in this class. Okay. Any other questions? Yep.
Can we have our headphones hooked up to our laptops or workstations in the lab?
You just want to hook it up to something so that you can
Get some music out of it.
Ideally speaking, I want it to be unhooked. Just have a headphone plugged in. Just that won't work.
That doesn't help at all now.
Okay, you can listen to my lecture again. Yep.
I have a question. For example, if we want to push something into the stack and then we want to pop it back, but not in, we want to pop it back 4 bytes greater than a register, like than EAX. How can we write that?
Can you repeat that question?
Okay.
Do you guys have a question? No? Okay. Go ahead.
So we want to put something, we want to push something into the stack and then we want to pop it back into 4 bytes greater than the register EAX. How can we write that down?
Okay, what do you mean by 4 bytes greater than the register EAX? Because the registers are not in memory space. EAX is not in memory.
So how about a memory space? 4 bytes greater.
It doesn't register because EAX as a register does not live in memory. So there's no such thing as 4 bytes above EAX. EAX can be used as a pointer. You can treat the content of EAX as an address. Is that what you meant?
Yes, that's what I mean.
Okay. So what are you pushing again on the stack?
Any doesn't really, for example, push. Let's define a label like that. X equals that.
It's hard for me to find out what you want to accomplish without a context.
Okay, so just give me an example. For example, if you have you want to push anything into the stack, like any variable, any label. I don't have anything specific. I just want to understand the concept
Of pushing?
How to pop it back into the address that you have in the context of EAX.
I think she used like asterisk EAX.
Asterisk EAX only works with jump instructions. That only works in jump instructions. Yep.
I think she may be referring to using EAX to store the stack pointer or where you were previously doing some things and then dumping that back so that you're using the right place in the stack.
Like a frame pointer.
Okay, are you talking about something like this? Like pushing a, say, constant on the stack and then pop it into something like this?
Yes. Yes, that's right.
And what about the question? What is the question?
No, I wanted to.
Or is that the answer?
I wanted to make sure I put the pop and how
Well, pop L can take any type of operand other than the immediate operand. So you can use a register operand, you can use a memory operand. A register operand is easy, just specify a register. A memory operand is just some memory operand that specifies a location, and that's it.
That's exactly what I wanted.
Okay,
Thank you.
great. Any other questions? Yep.
So we can't pop along in the value 23?
You can pop it into the location 23. You cannot pop it into the value
No, we want to pop
23.
into the value 23.
You cannot do that because you cannot pop into immediate. That's the only operand you cannot do when you use a pop.
And it makes sense.
And it makes sense. Right, exactly.
I want to overwrite constants of the universe.
42.
Okay, any other questions?
Let's do this exam.
Let's do the exam. Well, I have to go make some printout first. Yep.
Are we use the stack pointer at all in the exam, like ESP?
Yes, the stack pointer will be used. So the push and the pop instructions will be included. So you are expected to know what push, what pop will do, and what the stack pointer is about.
Okay.
We will not use the frame pointer. There's no question about the frame pointer or the concept of pushing parameters on the stack. But there will be push, there will be pops, there will be access to ESP directly, which is a concept that you have to understand anyway for call, return, push, and pop. Yep.
Will we be using call and return?
We will be using call and return. Yes, there will be call and return.
Okay.
Just like in the practice test has all of those elements as well. Okay. Oh, one more thing. Sorry, go ahead. Yeah.
Because you just said that the test is going to be similar to the previous one too, so it just different names of the labels, okay? Function name.
Different logic in the functions too. It's not going to be.
The program will do different things, but it is something that you have done already, but different in a way. Well, it's different from your homework assignment. I can tell you what it is already since the whole class is here, so I would not consider this unfair. It's going to be base conversion, okay? And base conversion you have done already, right? You have done base conversion. So this one is just base conversion, but with a little twist, okay? With a little twist. With a little twist, yes. Okay, one more thing is, the exam was set up so that I can give partial credit. Okay, it is all set up so that you don't have to rely on everything working to even get any points. Okay, so there are 3 components. There are 2 subroutines that I have written that contain bugs, and one that you have to write. But all three, okay, one relies on one other, but there are two subroutines that do not have any reliance on any other type of subroutines. So my suggestion is to work on those two first, okay? Because the third one does rely on one of the other subroutines, so you have to kind of get one of those working first before you can work on the third one. Yep.
What is the point breakdown on the individual subroutines and their functionality?
I do not have any point breakdown yet. Because I cannot assess how difficult it will be. I mean, I just cannot tell whether people will find, oh, this is easy or that's hard. Because I don't want to I don't want to make my marking scheme so that the difficult one gets too many points and then the easy one does not end up getting enough points. So I want to see what people do first, and then we'll go ahead and decide the weights on the questions. Yep.
I'd like to propose something.
Yep.
Everything on the test is worth 1 point, and then just turning something in is like 99% of points.
for just being there, being a warm body and be there. But that's discrimination against the zombies.
No, if they can submit something, they get a score.
No, the marking scheme is actually kind of written in the test too. When you look through the file, there's actually a section that talks about how I will test the program and how I will grade it. So each subroutine will get its own test cases. If it works for X many test cases, you will get points for that X many test cases for that subroutine. Yep.
Will the test still be available afterwards so we can go home and take it? Okay.
Yes. Well, the file is still there. I mean, remember, I give you one file. Oh, this is the other thing. Some of you will just get a crack out of this. Okay. The solution of your question is actually in the same folder, except it is encrypted. Okay. So here's the deal.